This is a video to help you start working more confidently with SI units, breaking things down. So, first of all, start by stating what the SI units are. We have length, we have mass, we have time, we have electric current, and Kelvin. I believe these are the major ones that we need to know how to play with. So, when we have a formula, that it will involve things like masses, accelerations, speeds, forces, voltages, all this kind of stuff. We need to know how to break them down fast, the shortest way possible. So I'm going to show you how I do this. Whenever I see a force, regardless of what kind of force it is, it could be an electric force, it could be a magnetic force, or an applied mechanical force. It doesn't matter, it will always have the same units of force. So whenever I need to break that down, if I've got a force or if I'm given newtons, it's the same thing. I go straight to F equals ma. I'm going to have mass, and then the units of acceleration are meters per second squared. So that's meters per second squared. Just practice that. Once you've got that in your head, that it's mass times acceleration, you can jump straight to that whenever you deal with force. Then whenever I deal with an energy, again this can be any kind of energy, I use mc squared. So that's mass, and this time it's speed, which is meters per second, but it's all squared. So the meters is squared and the per second is squared. Very small difference between force and energy. The next one, which a lot of people get stuck on, is voltage. Voltage is joules per coulomb. So that's energy over charge. We'll come back to this one, because first of all we need to know something for charge. So charge is equal to current times time. So that means the SI units of charge are just that, IT. So now I can go back into here, and if I want an SI unit for voltage, that means I'm going to use my SI units for energy and divide it by the units for charge. Then I can simplify that to that. We build up a list of these, and then hopefully we can do anything. So now, as an example, let me just write the voltage one again down here so I can have it all on one page. Okay, let's say I now want to examine power. A mechanical power is equal to the work done divided by the time taken. An electrical power is the voltage applied multiplied by the current passed through. Now I want to try and show that these two units are equal. So work done is energy, so that's going to be ml 2 to the minus 2 over time. And then I've got voltage, which is equal to that thing just above, and then current is just current. Now that's going to cancel with that one, and this t over here is going to become to the minus 3. Bingo. Nearly. There you go. Okay. So this was just one very brief introduction. I'm hoping that this very short example will give people that little boost to be able to try any of the formulas which are in the GAMSAT list. I've created a document which you can find. If you can't find the link to that, please message me. And I hope this helps.